So this is day one of the inverse functions section. We've already talked about some of this in class, but I wanted to give you guys a little bit of a review on it because it seemed like we were having some struggles in some of the areas, and for those of you that were gone, give you a chance to catch up on that. So first of all, what is an inverse? Okay, well, a word you can kind of associate it with is invert. So think about in your head if you invert a picture, or you invert your shirt, or if you invert a word, what are you doing to those things? Okay, well, some words that might be coming to mind are opposites. Take the opposite of something, or you flip it inside out, or you turn it, or you mirror image it. So think about like on a graph, if I invert something, I'm taking a mirror image of it, which, what is the word we talked about way back? Think about it. What's the word that goes with mirror image? It is reflect. Reflect. And I know there's some other ones we talked about, reverse, switch, opposite. Those are all good words. So put that down at the top of your notes page next to the question, what is an inverse? All right, so it says if the red line is the inverse of the blue line, how do you find the inverse? All right, so in class we talked about making sure you pay attention to those points because they tell you a lot about your graph. So if you need to, make those points really bold on your picture so that they're obvious. It's kind of hard to tell with my picture. Okay, so pause for a second and make some observations. See if you can come up with, if you have not already watched this video, see if you can come up with your own observations. Use your critical thinking skills to come up with some things that could be relating these equations. Okay, and then when you're ready, you can unpause. But for right now, pause, think about it. What is an inverse? Why are these graphs inverse of each other? All right, so if I look at my points, those of you that have thought about it or already learned it, this point is 0, 2. This point is -6, -2, because they go by 2's. If I look at my blue line, you'll notice that this is 2, 0, and this is -2, -6. Okay, well, very obvious observation there. The numbers flip. Instead of 0, 2, it now becomes 2, 0. Instead of -6, -2, it now becomes -2, -6. So inverses switch the x and y coordinates. That's a big part of inverses from a graph. You have to switch the x and the y spot, and we're going to talk about that in equations tomorrow as well. That's a real big part of that. If you look at their slopes, there's also something pretty important about those as well. So I'm going to erase that part right now. So if I look at the slope from this point to this point on my red line, that is a positive 4/6. It goes up 4, right 6. If I look at my blue line, it goes up 6, right 4. Look at that. What do we notice about our slopes? Okay, well, some of you might be saying they're flips of each other or they're opposites. They're not technically opposites. Think about, in your head, what is it called when you flip a fraction? There's an actual word for it. The slopes are reciprocals of each other. They're reciprocals. That means if it's 4/6 for one of them, it's going to be 6/4 for another. The last part of inverses that you should know is that they are actually a reflection. If I draw a line right down the middle of my graph, and it's always got to be right down the middle like this, and that's the line y equals x, by the way. If I draw a line through y equals x, cutting through the exact middle of the whole graph, my two lines should be a reflection across that. That means if I was to flip it or fold it right along this line, you should get the same picture on both sides, and it looks like I do. That's what makes an inverse on a graph. So pause here, write down those thoughts for that part of the notes in the box. All right, so on this one, once you get to this part, pause and try and draw this graph yourself. You should be able to. This is review. This is your y-intercept. -2/1 is your slope. Okay, so you start at the y-intercept. Again, this is review from algebra. You should know how to do this. If not, you had better be paying attention because you have to know how to graph. Not only for this lesson, but for many of the lessons in the future. Okay, this is your starting number. You always start with the number that's without the x. So go up to 4, put a dot. That's your y-intercept. Okay, and then you take your slope and you go down from there. Okay, so you go down to, that's -2, negative means go down, and right 1, not just over. Down to right 1. Down to right 1. I keep going until I get a good line. Some of you like to stop at 2, which is fine, but your graphs aren't the best, so you might want to keep going. If I want to go backwards, do the opposite. Instead of down to right 1, I got to go up to left 1, up to left 1, and then I get a nice, good straight line from that. Make sure to put arrows on both ends. And since it's our function, we're going to label it f of x. That's what f parentheses x means, function of x. So pause here, get that copy down, move on to the inverse. All right, inverse. We just talked about on the previous slide, all inverses is taking the points and switching them, and taking the slope and doing the reciprocal. Well, this point right here is 0, 4. This point right here is 1, 2. And this point right here is 2, 0. Just writing down my coordinates. To find the inverse, flip them. So 4, 0, 2, 1, 0, 2. These are my inverse coordinates. So now I'm going to graph them. 4, 0, 2, 1, 0, 2. Okay, and I can actually keep going because now I've got a slope I can work with. My original slope was -2/1. We said that inverses have reciprocal slopes, so flip it. Instead of -2/1, it would be 1/-2, but the negative on the bottom is kind of weird. We're not really used to graphing that way, so just move the negative up to the top. It doesn't really change it. It doesn't matter. As long as the whole thing is negative, it doesn't matter. Which means my slope of my green line is down 1, right 2. So I can continue my graph without having to plot every single point. I don't have to go back to the red line and switch every single point. I have to start with some points, but I don't have to do all 10 of them or however many there are. Make sure to label it. It is f with a little -1 of x. That means inverse function of x. Yes, you have to put that. Otherwise, you can't tell which graph is which. Pause if you need to, and then head on to the next section. Okay, this one should be exactly the same thing. Okay, I want you to try this on your own first if you have not already. If you've already done it, great. I'm going to just put it up here on the board so that you can check it. If you haven't done it though, again, pause, try it on your own. See if you can do it. Don't cheat yourself of actually learning it on your own. Okay, when you're ready, copy what I've got. Starts at 5, you go up 3, right 4. And to go backwards, you gotta go down 3, left 4. Getting it from these two things. Y-intercept, slope, original equation, boom, done. Down 3, right 4. Okay, and then draw it through. Again, this is my function. This is my f of x. To graph the inverse, either take the points and flip them, or start with 1 and work your way back with the slope. So I'm going to pick this one. This is 0, 5. If I flip it, that's now 5, 0. And I have a slope, instead of 3/4, it's got to be 4/3. So I'm showing you the slope version this time. So 5, 0 is right there. 4 over 3 is my new reciprocal slope. Notice I didn't change the sign. I didn't make it negative. It's still positive. So up 4, right 3. Down 4. 1, 2, 3, 4. And right 3. Down 4, right 3. And I have, oops, badly drawn, but I have my inverse graph. Again, check and make sure it looks like a good reflection. Draw your dashed line right down the middle, and it is indeed a reflection, so we're good. We're good on that one. Skip this one, go to this one. All right, quick review. We talked about this in the bell work on Monday if you were here. If you weren't, this is from a previous unit. Those are the numbers that we use every single time we have an x squared graph. Every time. So we're going to use it in the last example too. So 2, 4, 1, 1, 0, 0, negative 1, 1, negative 2, 4. Again, this is review. These are the same numbers we used back when we did the parabola unit. I'm not making them up. They're the numbers that we always used. The reason it's 2 comma 4 is because 2 squared is 4. 1 squared is 1. Notice my formula is x squared. If I plug in any of these numbers into my formula, I will get these numbers. That's where I'm getting it from. Okay, to find the inverse, flip all my numbers. Instead of 2, 4, 4, 2. Instead of 1, 1, well, it's still 1, 1, still 0, 0. Instead of negative 1, 1, 1, negative 1, and 4, negative 2. And graph. Here we go. Sweet. There's my inverse function. There's my regular function. Feel free to rewind if you need to, if you feel like I'm going too fast. I'm kind of on a time limit, so that's why I go speedy through some of them. Or pause if you need to. Last example, okay, we talked about way back. The number on the inside controls whether it moves left or right. Remember, it's inside opposite. Number on the outside controls whether it moves up or down. Since it's negative, it's opposite what we're used to, so we're going to go right 2. This is a review from our parabola unit. Plus 4 means up 4. So that means all those points I just did on the last problem, all of these numbers, the 2, 1, 0, negative 1, negative 2, 4, 1, 0, 1, 4, those are my starting points, but I got to move them all over before I can even start this whole thing. Okay, so all those little black dots I just put on there, they all have to move. Right 2, up 4. So take this guy, move it right 2, up 4. Put it at. Right 2, up 4. Put it at. Right 2, up 4. And then we get our new shape. Again, this is from our old unit. A little bit of review to get us going on that. Okay. Pause if you need to. I'm going to move on. For my inverse, I got to take all those coordinates and flip them. This point right here, that is 0, 8. So I got to change it and make it 8, 0. This guy right here, that is 1, 5. Now it's going to be 5, 1. This is 2, 4. Making it 4, 2. This guy right here is 3, 5, switching it to 5, 3. And last one is 4, 8, switching it to 8, 4. Okay? All that's getting graphed. 4, 5, 1, 4, 2. There we go. There's your inverse function. Just like it should look. Should be reflected over that diagonal line. Looks like it is. Here's my f of x. Here's that diagonal line I was talking about. Looks perfect. Perfectly reflected across it. Okay, fast forward or rewind, not rewind. Rewind if you need to or pause to get notes.